The Sun is a giant burning sphere. The existence of life on Earth depends on it. So in this video, today we are going to present many facts about the Sun. What is known as the Sun?
The Sun is a star. Our Sun is a 4.5 billion-year-old star and the largest object in our solar system. It is a huge, spinning, hot glowing ball of hydrogen and helium at the center of our solar system. The Sun is just like the stars that you see in the night sky. It appears so much larger and brighter than the other stars because we are so close to it. The Sun is the center of our solar system. All of the planets in our solar system, including Earth, orbit around the Sun. Its gravity holds the solar system together, keeping everything from the biggest planets to the smallest bits of debris in orbit around it. Without the Sun's energy, life as we know it could not exist here on our home planet.
How large is the Sun compared to Earth and how far away is it?
The Sun is enormous, compared to Earth. But our Sun is a medium-sized star with a radius of about 435,000 miles. Compared to Earth, the Sun is enormous. It contains 99.86% of all of the mass of the entire solar system. It would take more than 330,000 Earths to match the mass of the Sun, and it would take 1.3 million Earths to fill the Sun's volume. Earth is about the size of an average sunspot. The average distance from the Sun to the Earth is 93 million miles. Like all of the other planets in our solar system, Earth's orbit is also elliptical, like a stretched circle. It is not a perfect circle. This means that the distance between Earth and the Sun changes during a year. At its closest, the Sun is 91.4 million miles away from us. At its farthest, the Sun is 94.5 million miles away. The Earth is closest to the Sun during winter in the northern hemisphere. The Sun's nearest stellar neighbor is the Alpha Centauri triple star system.
What is the structure of the Sun?
The energy of the Sun is stored in the core and it is the main energy source of the Sun. Since the amount of energy produced is almost uniformly supplied, we do not see any significant change in its brightness or heat output. The core of the Sun is made of billions of atoms of hydrogen. The immense pressure and heat pushes these atoms so close to each other that they squish together to create new, heavier atoms. The second layer of the Sun is the radiative zone. Let's look up how to transfer generated energy. In this radiative zone, energy can be transported from the Sun's core to its surroundings by transferring it by radiation. Some atoms can remain intact in the radiation region because the temperature is slightly cooler than in the center. These particles absorb energy, store it for a short time and then release that energy as new radiation. In this way the energy generated in the core travels through one. The atom travels to another, upward path through the radiation zone. Number 3. The convection zone. Initially, the energy created in the core needs a new transport mechanism of travel to the Sun's surface after exiting the radiative zone. This is necessary because the temperature outside the radiation zone is relatively cool, about 2 million Kelvin compared to 5 million in the radiation zone. At this temperature, atoms will absorb energy very quickly. However, their surroundings are cold and dense, they will not release it quickly. Therefore, the transfer of energy by radiation is significantly slower. Furthermore, atoms are heated by absorption. Convection rises through the region and brings this energy to the surface. Number 4. The photosphere. The photosphere is also named the apparent surface of the Sun. Since the Sun is made entirely of gas, it has no solid surface. This is the visible surface of the Sun. This is the disk that one sees in the sky when one looks at the Sun through a telescope that has a filter. Number 4. The chromosphere. The chromosphere is the layer above the photosphere and is thicker than it. Number 4. The corona. It is the biggest and least dense structure of the Sun and it surrounds it. Furthermore, the solar wind transports the material of the corona out to the interplanetary medium. From Earth, the corona is only visible during a total solar eclipse.
How long does it take the light from the sun to reach Earth?
The light from the sun travels at the speed of light, 186,282 miles per second. The sun is about 93 million miles from Earth. Therefore, it takes the light about 8.4 minutes to reach us. This means that when you look up at the sun, you are actually seeing it the way it looked 8.4 minutes ago. The light from the next nearest star, Proxima Centauri, takes 4.3 years to reach the Earth.
How does the sun shine?
The sun, or any star for that matter, shines, or burns, due to a process of thermonuclear fusion, not due to a chemical reaction like the oxygen-driven fires on Earth. The sun shines by turning hydrogen into helium in its core. This process is called nuclear fusion. Fusion happens when lighter elements are forced together to become heavier elements. When this happens, a tremendous amount of energy is created. This can only happen in places which have extremely high pressures and temperatures. At the center of the sun, the temperature reaches 16 million Kelvin, and the pressure is more than 1 billion times the atmospheric pressure on Earth. The sun converts about 5 million tons of mass into energy every second. This energy heats the sun, and in turn, the sun heats Earth and all the other planets. The sun has been shining for about 4.6 billion years, and it will continue to shine for about 5 billion more years. Because in about 5 billion years, the hydrogen in the sun's core will run out and the sun will not have enough fuel for nuclear fusion. So, in about 5 billion years, the sun will stop shining.
What are the sunspots and why do they appear dark?
Sunspots are temporary areas on the surface of the sun that are cooler than the surrounding areas. They are caused by intense magnetic activity that inhibits convection and reduces the surface temperature. However, even though they appear dark, they are still very hot. Sunspots have temperatures around 6,300 Fahrenheit, while the surrounding surface of the sun has a temperature of about 10,000 Fahrenheit. The average sunspot is about the size of the entire planet Earth. However, sunspots come in a variety of sizes ranging from hundreds to tens of thousands of miles across. They appear and disappear on the surface of the sun.
Does the sun spin?
Yes, the sun does spin. The sun is located in the Milky Way galaxy in a spiral arm called the Orion Spur that extends outward from the Sagittarius arm. Our solar system is moving with an average velocity of 450,000 miles per hour. But even at this speed, it takes about 230 million years for the sun to make one complete trip around the Milky Way. Since the sun is not solid, different parts rotate at different rates. The sun actually spins faster at its equator than at its poles. The sun rotates once every 24 days at its equator, but only once every 35 near its poles. The giant gas planets, Jupiter, Saturn, Uranus, and Neptune, also spin faster at their equators than at their poles. The sun's spin has a tilt of 7.25 degrees with respect to the plane of the planet's orbits.
Why is the sun round?
The reason that the sun and most large objects in space, like stars, planets, and large moons are round is that they formed and collapsed under the force of their own gravity. Due to the effects of rotation, the sun is not a perfect sphere. It bulges out slightly at its equator.
What happens during a solar eclipse?
A solar eclipse occurs when the moon gets between Earth and the sun, and the moon casts a shadow over Earth. During a solar eclipse, it gets dimmer outside as more and more of the sun is covered by the moon. During a total eclipse, the entire sun is covered for a few minutes and it becomes very dark outside. The temperature outside also drops.
Why is the sun called Sol?
The sun has been called by many names. During their empiric reign, the Romans continued to worship several sun gods. Solis is Latin for sun. Sol is the Roman equivalent of the Greek sun god Helios. And maybe in earlier times English speakers did use these names. The most powerful sun god in ancient Rome was Sol Invictus, meaning unconquered sun. The first cited use of Sol as a proper name for the sun is the 1450 Ashmole manuscript treatise on astrology, which stated,